So in the previous video I promised you that this was actually 4 or 5 calculating machines. So you can see where that comes from, in the sense that you have 3 front registers and 1 rear register, which are all separately accumulating totals and can be transferred from one to the other. However, what they can't do is multiply. If you put a number into the machine and add it, then the number is gone. So your pincushion where you enter numbers gets reset after every number that you enter. So multiplying by repeated addition is a bit difficult. So the machine doesn't attempt that. It actually uses a separate machine at the back here for doing multiplication. And multiplication is an operation that only happens into the rear register, so the front registers don't do multiplying. Whatever result of the multiplication goes into the rear register. And the way that this works is by using this little gizmo to enter numbers. And then it's actually quite interesting to see this happening. So I will try and demonstrate it, and I will enter a number into the multiplier. So the number that I'm going to enter is 1, 2, 3, 4. So I have entered that into the pincushion in front, which interacts with the rest of the machine. You can actually see it over here. So it has 1, 2, 3, 4 in the pincushion, which you can't really tell, but believe me, it's there. So what will happen now if I press the extend button in order to put this number into the multiplier is that it will get this number into the top part of the machine, as it did the last time when we printed the number, and print it. But it will also engage this mechanism down here, where your type bars, or when your toothed bars at the top here, they engage with these levers that run down and they pivot all the way at the bottom of the machine. And what you can see is that there are hooks about this height that have a separate pivot that they can turn on, and they hook into these bars over here that run back into the multiplier. And these bars that run back into the multiplier, they engage with this little gizmo over here for every one of these sliders. And so what will happen if I turn the machine is, let's see if we can get that to work. So we've entered the number, we've pushed extend. So the type bars, well, we need the motor bar, of course. So motor bar. So what we see is that the type bars, or the longitudinal bars at the top, will start moving and read the number in the pincushion. And at the same time that they start moving, you see that this mechanism over here engages with the teeth in these bars over here, and you can actually see that the sliders are being pulled to the front in that way, and they hence read out and transfer the number that is being printed. Listen for the hammers. There we go. They put it into the multiplier. So you can transfer a number that you put into the keyboard into this multiplying part of the machine. And then the question is, how does it multiply? So you have these sliders over here that have a kind of tail that sticks down into the machine, and so these here are the tails. And then you have, in this part of the machine, you have a mechanical memory that that has a plate for every table of 10, a lot like the Millionaire has a block that is like that. Here it is separate plates. And so what will happen when you press a multiplier key is that one of these plates will get activated. So I put in 1, 2, 3, 4. So I would suggest to multiply that by 3. And so the table of 3 for 1, 2, 3, 4 would be 3, 6, 9, 12. So the 4, this bar that is set to 4, should be subject to a 1 in the tens category, while all the others have a 0 in the tens category. And then the next time we should see a 3, 6, 9, 2 happening. And so if we do that, if we press the 3 button, there we go. So I don't know if you were able to follow what happened, but we activated the 3 down here. And so then immediately the motor starts running, and look what happens. We start the rotation of the machine, and you see that there is a part coming up and is actually lifting the first plate up, and that plate engages with these bars that run transverse in the machine, and so they then engage with that tail that sticks up. And you see that actually for the table of 3, you can actually nicely see it here. It is 0, 0, 0, 1, 1, 1, 2, 2, 2, because those are the first numbers in the table of 3 for the tens. And so what happens is that you lift the tail that reaches down to the bar that represents 4 and is hence set at 1. If you look to the side, you can see that that first shaped plate, stair-shaped plate that is set to 4 is now sticking up 1 position. And the result of that is that the step in the plate will stop the type bar at position 1. So we lift it up, and you see the type bar starting its travel and stopping at 1. So this doesn't print, but it does take it into the rear register. So the 1 goes into the rear register for the number that is set to 4. Then the whole thing comes back down. There we go. And then the machine starts a second cycle. And so in the second cycle, the plate for the units is lifted. And so the plate for the units in the table of 3 would be 3, 6, 9, 2. And so we'll see that happening. We'll see the 3, 6, 9, 2 over here engaging with these plates, and hence lifting the stair-shaped plates up, and hence engaging these bars in the positions 3, 6, 9, 2. And then that, when they run back, also goes into the rear register. And the rear register, this is also interesting, The rear register is what actually moves. So you see this part over here. Actually, the rear register shifted to the right top on your screen. So it's actually, it was sitting one gear over downwards. So that the first plate that got added was the tens, and now these are the units. So they get added, and let's see if we can actually see that somehow. So we'll bring things back down, and the type bars will come back, and you will actually see you should have seen the gears rotating, but I'm not sure you did. So that is how the thing multiplies. And then I promised you a fifth calculating machine, sort of. And the reason for that is because with the machine arranged in the way that it is like this, what you cannot do is subtract. Because if you run the machine backwards, it's always so that the bars running forward reads the register, and the bars running backwards adds to the register. So subtraction is not possible, you're just reading the register. So there needs to be a special part of the operation where a number is converted into its complement. So you can add it to a register because you can only do addition. And ingenious as they were, Moon and Hopkins decided to do that with the subtractor as well. And so you see that we still have this number sitting, 1, 2, 3, 4, sitting in the multiplier subtractor. If we push the subtract button, what will happen is that we will subtract this number from the rear register. So whatever is currently set in the rear register, we are going to subtract this number from it. And so if we push the subtract button, like so, then you see that the multiplier is used in the same way as it uses the table of 10. The multiplier is now used to lift a plate. You can actually see that happening over here. So it's used to lift a plate that converts 1, 2, 3, 4, 5, 6, 7, 8, 9 into 9, 8, 7, 6, 5, 4, 3, 2, 1. And so every number that is set in the multiplier subtractor now has a plate that is lifted to the height of its complement, and the bars run in until they reach their complement. So whatever is a 0 becomes a 9, whatever is a 1 becomes an 8, whatever is a 2 becomes a 7, etc., etc. And hence this complementary number gets added to the rear register, and in that way is subtracted from it. So that's the guts of the machine, if you like. What I will do now is start the motor and show you also the front of the machine to explain to you the operation, put in some paper, and then we will do some calculations.